In our last lesson, we learned how to graph a linear equation using our slope-intercept form. For this class, today our goal is to graph a linear inequality using the slope-intercept form, okay? We spent some time working on it yesterday. We will spend a little bit more time working on it today. So let us go ahead and begin. If you remember the notes from yesterday, or our last session of notes, we had our essential question being how to graph, or how can I draw a graph when given the slope intercept form. For this one, we are going to be how can I, goodness, I can't type. How can I graph a linear inequality given, or using, I should say, using slope intercept form. We want to use slope intercept form, not slop. Slope, slope, slope. All right. Um, okay. I need to check to make sure I share my screen. Forgot and thought I wasn't. So just as a little reminder, this sign here, this little sign here, this is going to be our less than sign. In case you've forgotten, this one here is going to be greater than. This one here is going to be less than or equal to. Let's move that over a little bit. And this one here is going to be greater than or equal to. All right. So that's just a quick little uh, reminder of what these signs mean. And now let's actually get into the meat of the notes, the bulk of the notes here. Excuse me. So this first thing says a point is a blank to an inequality if it makes the inequality blank. And if you remember with these, back to our inequality set of notes, a point or any value will be a solution to an inequality if it makes the inequality true. All right. If it makes the inequality true. If the inequality continues to make sense. Okay. So let's look at that real quick. This says determine which of the following points is a solution to the inequality y is less than or equal to 2x plus 4. Okay. So to do this, we're going to see if, in order to check whether the point is a solution, we're going to plug it into the equation. All right. We have our x here and our y here. I'm going to use I as my example. I'll probably do 1 and 2, and then you all will do 3 and 4. So let's begin. We're just going to simply plug these right into their place in this equation. We have y equals 2x plus 4. So this new equation is going to be, instead of y, we have 6. You know what? I'm just realizing that my y kind of looks like an x. So let's erase that and rewrite it. Y. There we go. And when we type this in, or when we make this new equation, we end up with 6 is less than or equal to. And the way I'm typing that, I'm just typing the less than sign and then hitting the equal sign on my keyboard. Less than or equal to 2. And then what is my x? My x is 0 plus 4. So I've just retyped the original equation with my values plugged in. When I go to solve this, I end up, so I have this 2 times 0. 2 times 0 is 0 because any number times 0 is 0. And what I'm left with is this 6. 6 is greater than, or is less than, excuse me, less than or equal to 4. Is that a true statement? That absolutely is not a true statement. So this is not a solution, okay? this 6 is not greater than, or this 6 is not less than, 6 is not less than 4. So this is not a solution, okay? Not a solution. Not a solution. All right. I'm going to do this one next, and then you all can do the other two. Okay. Actually, no. I think you get it from there. You all can do these three. You guys kind of get the point. If you don't get it, come back to the Zoom or come back to the class meeting and ask me there. All right. Let's look at this next one. Determine which of the following points is a solution to the inequality 3x plus 9y is less than 18. Okay. Same exact scenario here. We are going to have our x value and our y value. To check whether it's a solution, we're going to substitute those values into their respective places in this inequality. So our 2, which is in our x place, is going to go into this x here. Let's make that the same color. This x here, underlined in purple, is going to go with that x. And then this y is going to be this 2. They just both happen to be 2. So when I go and I substitute these two in, I end up with 3 times my x is 2. 3 times 2 plus 9 times my y in this case is also 2 is less than 18. And so what we'll do is we'll just go right through and calculate this. If you have your Desmos up, you can go ahead and type this right in. I think I'm good without Desmos, so I'm just going to do it in my head. 3 times 2 is 6. And I'll type out each of these things. 6 plus 9 times 2 is 18. Is 18 less than, is 6 plus 18 less than 18? Absolutely not. When we do 6 plus 18, we end up with 24. So is 24 less than 18? It absolutely is not. And so this is not true. This is going to be no solution. Let me scoot these up so we got more space to write. I just like to align my my signs. So this here is no solution. This is not less than 18. No, or not a solution. I should just type it out. I don't know why I decided to write it. All right. So now we know how to check whether a point is a solution or not to an inequality. Let's move on to this next step. The goal of this is to be able to read equations and graph equations using slope-intercept form. Read inequalities and graph inequalities using slope-intercept form. Sorry about that. So let's go through a few steps for how to do this. Step number 1 is going to get the inequality in slope-intercept form, okay? So this is going to be something that looks like, instead of being equal to, it'll be less than or greater than. No, I won't do that. It'll be less than or greater than, or less than or equal to, or greater than or equal to one of our inequality signs. And then we'll still have that mx plus b. That'll still be the same. The only difference here is that we are using inequality symbols, signs and symbols, instead of an equal sign, right? Our step number 2 is going to be to graph the y-intercept and use the slope to graph. Instead of another point, we're going to graph 2 more points. So that way we have 2 points to use, or 3 points total to draw our lines. So this won't say another point. To graph 2 more points. Okay? And then we're going to determine the type of line. If you think back to how we graphed inequalities when we were solving those things, we had open circles and closed circles. Since we're dealing with lines, we're going to kind of have open lines and closed lines. But the way you could think about that, our closed line is just going to be a solid line. So we'll have a solid line for when it has that equal to, or when the line is underneath the symbol, we'll have our line be solid. And if it's just less than or greater than, it'll be a dashed line. So kind of, you can think of that as being open. That line has openings in it. It'll be open. And then you're going to determine your shading. That's the big difference between inequalities and equations. If y is greater than or equal to whatever comes after it, we are going to shade above the line. All right. And if y is less than or equal to, we're going to shade below the line. All right. And then we're going to identify the quadrants that the solutions are in and at least 2 points that are solutions. Okay. If you don't remember what quadrants are, I'll do a quick little graph down here for you to look at. So here we have our x-axis going side to side and our y-axis going up and down. When you think of our quadrants, we have quadrant 1 in the top right, quadrant 2 next to it to the left, quadrant 3 in the bottom left. And these are written as Roman numerals. And then quadrant 4 is the bottom right. All right. So let's actually look at an example. This example here to the left, or to the right, excuse me, says graph the following inequality. So first, we're going to get the inequality in slope-intercept form. This one also already happens to be in slope-intercept form, so we don't have to do that step. That step's taken care of us. If you want to continue doing it the way we did yesterday, we can identify our slope first and our y-intercept, so that way we know what we're going to be doing. So our b is -5, and that's going to be at 0. -5, that's going to be the point there. And then we also have our slope, which is 2. So m equals 2. And anytime we have a whole number, we're just going to go ahead and put a 1 underneath it. So we have our rise over our run. Okay, so anytime you see a whole number, just go ahead and draw 1 underneath it for your slope. So now that we have our slope and our y-intercept identified, we're going to plot our y-intercept, which is going to be at 0, -5. 0, -5 is going to be going down on the y-axis. So we're going to start at 0 and count down 5. 1, 2, 3, 4, 5. Put a point there. And then we're going to plot our slope. Our slope is 2. And then we put it over 1, because that's what we do with whole numbers. We put whole numbers over 1 when they are slopes. So we're going to rise 2 and go to the right 1. Go 2 in the positive direction, rise 2 in the positive direction, and 1 in the positive direction, run. So up 2, 1, 2 over 1. Up 2, 1, 2 over 1. And honestly, you could do a whole bunch more points than just 2. Up 2 over 1. You could keep on going. Since slope is a constant rate of change, you can go as long as you want. 2 points will help us make sure we get a straight line when we do it. And that's why we ask you to do at least 2 points. All right. Now that we have that there, we can go ahead and plot. So I'm going to draw from that last point I made all the way to this first point. And here we have a line. I'm going to actually go ahead and extend this all the way through. And then I'll also go up just so we can see what it looks like. Now, my line might be a little bit off since I didn't draw all of my points, but that's what it's going to look like, okay? So now that we've determined the type of line that this is going to be, actually, I need to do this a little bit differently since this is an inequality. Now that we've determined where our points is, we have to determine the type of line that we're dealing with, whether this line is going to be dotted or dashed. You can tell whether it's going to be dotted or dashed, whether or not the inequality has that equal to sign. If it has the equal to sign, then it's going to be a whole. It's going to be a solid straight line. If it doesn't have the equal to sign underneath it, then it's going to be a dash line. So this here is going to be a dash line. I wanted to draw it, but or use that tool, but I'm going to have to actually just draw it by hand. So my draw tool working? It is not. All right. I have to draw it using the mouse. That's not a problem. It just may look a little funky. All right. So that's what our line is going to look like. It's going to be a dashed line going through our points. All right. So that's one of the changes with doing inequalities. And now we have to do the second change, which is going to be to shade it in. Now look, it says if y is greater than or greater than or equal to, we're going to shade above. If it's less than or equal to, we're going to shade below. In this case, we have y is less than, so we are going to shade below. And I'm going to do that in the, let's do that in this green color here. All right, so this is going to be our solution side for this inequality. And then finally, we're going to identify the quadrants that the solutions are in and at least 2 points that are solutions, okay? So this solution, it covers quadrant 1 and quadrant 4, and a really tiny bit of quadrant 3. So we're going to include that bit as well. So remember quadrant 1, quadrant 4, quadrant 3. We see the examples down here. So let's go ahead and write those quadrants out as part of our solutions. So 1, and I'm going to write them in order, 1, 3, and 4. And then 2 points, at least 2 points that are solutions. Doesn't really matter what points they are. You could pick something. You could honestly, I'm going to make my points really big and obnoxious so you can see them. You could pick that point there, this point here, and this point here. It doesn't really matter which points you choose, just as long as you choose points that are solutions, all right? But we prefer you vary it up a little bit. So if you want to pick all those would be what? 1, 2, 3, 4, 5, 5, 0, 7, 0, and 9, 0. All right. So 5, 0, 7, 0, and 9, 0. Okay. So there we go. We have an example done. I'm going to do another one because these are kind of confusing and you'll be able to do this very last one here. So this says graph the following inequalities. First step is to put in slope-intercept form. This one is in slope-intercept form. I'm going to add in 2 additional steps. Identify your slope. So we have m is equal to 1 over 2. And then identify your y-intercept. We have b is equal to 3. And that's going to be we're going to plot that point. That's going to be plotted at 0.03. And now we actually continue with the rest of the steps. We're going to plot that 0, 1, 2, 3, plot our y-intercept, and follow up by plotting 2 more points using our slope. So this is going to be rise 1, run 2. That's a tongue twister. Rise 1, run 2, 1, 2. Go up 1, go to the right 2, 1, 2, up, over, up, and over. You can keep on doing that more and more and more and more. Now this has no equal sign underneath this inequality. So this is going to be a dashed line, all right? And then since this is, let me actually extend all the way this graph some more. With these, you want to extend them all the way to the ends of the graph so you can get an accurate representation of how many quadrants it's going to cover. And then my next step, we determine the type of line it is. We're going to determine the shading. Is it going to be above or is it going to be below? This says y is greater than. So when we have greater than, we're going to shade above. So this is going to be, let's use this bright green color. All this gets shaded. All right. And then finally, we're going to identify the quadrants that the solutions are in and at least 2 points that are solutions. So what quadrants are covered? We have, let's don't forget this part down here. We've got quadrants 1, 2, and 3, okay? So quadrants 1, 2, and 3. Those are all covered. And then let's pick 2 random points I'm going to pick this point here. Let's go at this point here and this point here. And then we're going to plot those points. So that point, this point here is going to be 0, 1, 2, 3, 4, 5, 6, right? 6, 0, 6. This point here is going to be 1, 2, 3, 4, 5, 6, 7, 8, 0, 8. And then this point here is going to be, not 0, 8. It's going to be 8, 0. 8, 0. And this last point is going to be 8, 1, 2, 3, 4, 5, 8, 5. All right. You all do 3 on your own. You have to make sure you put it in slope intercept form first. Okay. Do that and then continue with everything else. So example 4 says, which of the following inequalities matches the graph? So what we're going to do, we're going to look at each of these and see which ones work. And we're going to cross out some that don't work. So we see that this line is dashed. So this means we're not going to have an equal to underneath our inequality. So it's not going to be A and it's not going to be B. Without doing any work, we know that. And then we have shading above this line. So since this shading is above this line, we know it's going to be Y is greater than. The only one that has Y greater than is going to be C. So without doing much work at all, we figured this one out. This one was pretty easy. You all can use the same tactics for the second one, but you're going to have to put it in slope intercept form first. So you all go ahead and do that. Okay. Finally, we'll do this big old problem here. This is an application problem. So this is going to pull in a bunch of different areas of thinking. This says a company makes nylon and canvas backpacks. The company makes a $3 profit on nylon backpacks, and a $10 profit on canvas backpacks. How many backpacks must be sold to make a profit of more than $200? So what are we trying to find? What are we trying to find? We have steps to go through. What is it that we are looking for? We are trying to find how many backpacks must be sold. B says, what are we given? I don't have to write this one out. We are given it tells us they make $3 in profit. Oh, don't do that. Let me do that. $3 in profit from nylon. I'm just going to type this out. I don't know why I'm writing it. They make $3 profit from nylon backpacks. And so you all may have to read this question multiple times to get all this information. They also have $10 profit on canvas backpacks. And we want our profit to be more than $200. All right. And that's just like right here. How many backpacks must be sold to make a profit of more than $200? So profit of, or he wants a profit of more than 200 smackaroos. All right. So our variables, we have X as our nylon backpacks. It could be anything, but we'll go with what we know. X is our nylon and Y can be our canvas. And I'll write those two in. Actually, now I'm just going to type those out. We can make X equal nylon and Y equal to canvas. And then we're going to write a linear inequality, okay? So if we know there's a profit of $3 from nylon backpacks, we know we're going to have, do this one in black, we're going to have $3 for every nylon backpack we sell. Excuse me, 3x. So 3x. And then we also make $10 from every canvas backpack we sell. So 3x plus 10y. I mean, we want our entire profit to be greater than $200. Excuse me, I got hiccups. Our entire profit to be greater than $200. Okay. All right. So I've helped you all set this problem up. You all go ahead and finish it up, graph the inequality, and then identify two solutions. Okay. If you run into trouble, let me know and I will help you out. All right. That's what I'm here for. Ask questions if you don't know how to do parts of the notes, and we will get through it. Okay.